This is Steve Fowkes, welcoming you to the 8th mini video for this presentation. Finally, we get to the huge and vitally important topic of inflammation.
Inflammation is the core of one of the oddest puzzles of Alzheimer's disease. In a disease that is positively associated with mercury as a risk factor, why does the consumption of fish, which contains elevated levels of mercury, actually lower Alzheimer's disease incidence? The statistical evidence that fish consumption lowers Alzheimer's incidence is quite robust. So how could this be true? The answer is that fish contains anti-inflammatory fatty acids. Because inflammation is a much more important risk factor, the mercury exposure is a comparatively minor contributor. Inflammation is known to be associated with degenerative diseases of many kinds. Furthermore, inflammation is known to be associated with many neurological diseases. So we can only conclude that inflammation is a bigger risk factor than mercury exposure, and clinical efforts should have a primary focus on controlling inflammation. There are several mechanisms of inflammation that may have a direct bearing on Alzheimer's disease. One of the primary responses of inflammation is the induction of cytokines, which are cell signaling factors that mobilize and coordinate the immune system towards potential infections and allergens. One of the things that cytokines do is to activate other enzymes, two of which are aromatase and IDO, which is an abbreviation for indoleamine dioxygenase. Aromatase and IDO have survival value in fighting infections.
Aromatase increases estrogens. It does this by converting testosterone to estradiol and androstenedione to estrone. The advantage of this is that estrogens turn off genetic transcription and protein synthesis, which decreases any collateral DNA damage that might otherwise occur from the oxidants and free radicals that the immune system uses to fry infectious bugs. The bad side is that estrogens inhibit energy systems that would otherwise maintain ATP synthesis and antioxidant recycling. The decrease of testosterone and progesterone by aromatase also decreases energy production. The enzyme IDO breaks down tryptophan, which is an amino acid that some infections need in order to thrive. But decreased tryptophan causes decreased serotonin and decreased melatonin, which you need for happiness and well-being. In addition, low serotonin causes depression, increased sensitivity to pain, and impairment of sleep quality. And the combination of poor sleep and low melatonin cause neuroendocrine dysregulation.
In addition to the alterations of the testosterone-estradiol ratio, the progesterone-estrogen ratio, and the androstenedione-estrone ratio, the downregulation of energy pathways inhibits steroidogenesis at its root. This decreases the neuroprotective effects of pregnenolone and progesterone and sabotages the pro-energy effects of progesterone and testosterone. Let's look at this in more detail. The steroid tree shows the metabolic paths of steroids. The root of the tree is cholesterol, which is the ultimate source for all steroids. The trunk of the tree is pregnenolone, which is the point at which branching begins. For neurological conditions, the neuroprotective steroids are at the base of the tree, with pregnenolone and progesterone being the strongest, and DHEA being a very weak third. The androgenic steroids are on the left, with DHEA being quite mild, and testosterone and dihydrotestosterone being quite potent. These hormones play a significant role in upregulating energy pathways, along with progesterone. The estrogenic hormones are at the top of the tree, with estradiol and estrone being the strongest. The flow of steroids into the estrogen section of the tree is regulated by the aromatase enzyme at these 3 points. Increased aromatase activity increases estrogenic influence, which downregulates energy pathways and decreases estrogen precursors, which would otherwise support the energy pathways.
And the neurotoxic hormone, cortisol, is on the right side. Cortisol tends to increase markedly to compensate for low metabolism. The shift from a pro-energy, neuroprotective steroid pattern with progesterone, testosterone, and pregnenolone to an anti-energy, neurotoxic pattern with estrogen and cortisol is potentially catastrophic to the brain when the mercury-glutathione balance is weak.
The sources of inflammation are legion. The most familiar are infections, which span the range from the high profile, like viruses, bacteria, and fungi, to the more obscure, like toenail fungus and anaerobes in root canal teeth. Allergies are another category that deserves elaboration. Immediate hypersensitivities are obvious to everybody, to both medical professionals that test them with skin injection challenges, and to patients who experience rashes, welts, and boils within minutes to hours of exposure. However, delayed hypersensitivities are an entirely different kind of allergy. They are mediated through IgA, IgG, and IgM antibodies and are not immediately obvious to the people who are exposed. They are popularly called food allergies, and their pathologies and their inflammatory influence has been denied by most medical allergists for many decades. Their adverse influences are greatly magnified by digestive weaknesses, use of antacids, use of H-blocking anti-indigestion drugs, and by leaky gut syndrome. Many common foods, like wheat, corn, milk, and yeast, are among the highest risk for delayed hypersensitivities. So are personal favorite foods, which produce short-term feelings of well-being at the earliest stages of inflammation. Oxidative stress is a general inflammatory influence. This can occur through heavy metal exposure, which poisons enzyme systems, or from nutritional deficiencies, which can undermine antioxidant systems. Also worth mentioning are chemical exposures, like pesticides from agriculture, and aldehydes from particle board, glues, and carpeting, and from lifestyle factors like alcoholism. This page is just a cursory exploration of this topic. The brain is only 3% of the body's mass, but consumes 20% of the body's energy. This disproportionate energy use is required to power the microtubule transport system and the phosphorylation cycle. These brain systems require the robust energy that can only be derived by aerobic energy processes. They are also highly sensitive to mercury toxicity, which is otherwise controlled by binding to glutathione and by the energy-driven recycling of glutathione. Glutathione is the critical process for preventing and reversing Alzheimer's disease.
If you want to go on to hear about at-home testing options, how to get in touch with me, or supplemental slides dealing with dental risk factors, start Part 9 now.